As I said earlier, as co-chair, I got assigned anything that John didn't want to do. And so I was assigned to synthesize what we've all seen over this period. And then he gets to come and do an appraisal afterward and tell you whatever I said was wrong, I guess. This is actually more of a recapitulation than a true synthesis. I want to remind you of the kinds of things that you've seen. Okay, for instance, we saw about competing technologies. Here we've got a carbon burning engine, and here we have a uranium burning engine. You may recognize that as a model of the Timberwind, single part of it, and that is a coal burning train engine. And remember, competing technologies may end up being complementary technologies. We saw this earlier, where chemical-powered rockets need not be viewed just as competition to nuclear or vice versa. If we talk about different roles for each, they can be complementary. Now, I want to go through and just remind you of what we've seen. Okay, Morgan Smith was from Y12 and talked about historical initiatives, had strong support for us, gave us that stem-winding speech about technology breakthroughs and synergies. John Vonglis from DOE's ARPA-E told us how about the mission and how it fit with our symposium, and I categorized his talks as technology breakthroughs and synergies. Alan Eisenhower talked about synergies and technology breakthroughs. There's this guy, Mark, what was his name? Mark Uran, that was it, who told us about the prerequisites for a decadal plan and talked about reality. Okay, looking at these things, these are the categories that I'm using to put these things together in. Propulsion and transportation, power, superconductors, materials and uses, environmental control and life support, technology breakthroughs, decadal plan, and new understandings in science. And then conceivable human modifications. We saw that from Bren. Okay, reminding you about theme 1. We had John Mencken's The Moon is the Stepping Stone, Environmental Control and Life Support. Franklin Chang Diaz, Humans are in space to stay, require 2 things, abundant electric power and a paradigm shift in propulsion. He covered environmental control and life support, power, propulsion, and transportation. James Powell didn't actually talk, but we had John Mencken's talk for him about particle bed reactors, superconducting maglev, and that covered propulsion and transportation, environmental control and life support, superconductors, and materials and uses. Michael Houts talked about nuclear thermal propulsion and the Y12 kilopower project. One note that I took in there was that he showed us that there's a political thing about highly enriched uranium versus, what is it? Is it low enriched uranium? And so for civilian uses, we've got a thing that says we're not using HEU. Talked about propulsion and transportation and power. Joel Sorcell, asteroid capture and asteroid use. I classified most of what he said in materials and uses. So talking about what we saw as a whole in Theme 1, we had these enabling large-scale development and human expansion topics, and motivations led to this need for breakthrough technologies, and then on to Theme 2. I'm zooming through this. I hope you appreciate it. All right. In Theme 2, we had Jason Derleth told us about NIAC, told us about exploration of technologies, told us about technology breakthroughs. Jonathan Winter told us about particle bed reactor, nuclear thermal propulsion and power. So he's propulsion and transportation and power. Roger Leonard, LEU pebble bed reactor and power system, propulsion and transportation and power. Philip Lubin, directed energy propulsion, power beaming, that relativistic flight requires photonic engines. You remember he said all of the stuff in the universe using chemical energy wouldn't propel one proton to light speed or near light speed. Just a matter of physics. Robert Bagdigian, environment, and I apologize, those of you who look in your programs, we left out an I in his name, and it was my fault. It's Bagdigian. Environmental control, life support. William Peter told us about large-scale 3D printing, composites, use in space exploration, and gave us a little bit of honesty here that we aren't there yet in using regolith for 3D printing. Materials and uses. Jeffrey Slostad, in space manufacturing supply chain, service chain, water as a critical resource, robotic servicing and assembly, so classified as materials and uses, environmental control, and life support. Mark Carter talked about the Vasimir plasma propulsion, supporting deep space missions and cislunar tugs, propulsion and transportation. Ken Roy, low gravity problems for humans, centripetal acceleration and using circular craters, materials and uses, environmental control and life support, and superconductors. Siegfried Janssen, fabric, I like that, fabric spacecraft with muscles for debris removal and exploration, and he also got to mention a little bit about smart propellants. So we got propulsion and transportation there. So we came from Theme 1, and we got things in propulsion and power and other things, and we're going on to Theme 3. Matt Hollingsworth talked about how to make big ideas a reality and how to worry about the funding gap, technology breakthroughs. James Early, habitats, advanced exploration, propulsion options, materials and optics, environmental control and life support, propulsion and transportation, and materials and uses. John Rather, capture of small asteroids, industrialization of asteroids, and other good stuff. Materials and uses. John Mankins, affordable solar energy, abundant solar energy, power. I was in there, I talked about integration, and I classified that as decadal plan. All right. We've got, you can get this on the internet, the current NASA plan that goes from now through the 2020s to the 2030s, going to Mars and phasing. What we're talking about is acceleration. We got the now, we got the 2020s, but we'd like this to be 2030. We'd like to get there sooner. If you can't read it, I will read it for you. Alas, poor Barsoom, where now are your canals, your green and red Martians, John Carter and Deja Thoris? All right, theme 3, we talked the decadal plan, vector shift, environmental controls, power, technology breakthroughs, going to a 10-year Mars expedition, and then on to theme 4. Okay, here we are at theme 4. We had Catherine Asaro. You say it Asaro, is that correct? Asaro. Huh? Asaro. Asaro, okay. I thought it'd be nice if I pronounced it correctly. Plausible extrapolations of known science to make space travel feasible for longer distances. I classified this as new understandings. Mark Millis, purposeful search for novel technologies through science fiction, technology breakthroughs. David Brin, biomodification of humans, silicon humans, examine ramifications with science fiction. Are you hearing science fiction a couple of times here? Classified it as human modifications, but I'm hearing that science fiction as a common theme. Arlen Andrews, repurposing asteroids, measuring value. Science fiction as Gedanken experiment. Materials and uses, environmental control, and life support. Ruth Kastner, transactional interpretation of quantum mechanics. Loopholes, anybody? Grist for science fiction, new understandings. Buck Field, history of revolutionary ideas, technology breakthroughs. Alan Steele, evolution of starships in science fiction explores concepts, propulsion and transportation. So, from theme 3, we've got this environment of science fiction, and we've got continuous things, and we've got solar system things and transsolar things, and through science we get to interstellar expeditions to the future. So, what can I say in conclusion? Well, we talked about this earlier. We've got our plan for the various pieces and the things we do during it in the next 10 years, but theme 4 adds, don't stop. Technology enablers, okay, I'm just repeating these things that we saw before in the propulsion and transportation. There was nuclear thermal propulsion, Vasimir chemical, and power. There was nuclear and solar. Materials and uses, we had lunar regolith and asteroidal materials, additive manufacturing, solar concentration, superconductors, and we had environmental control and life support, and we had synergies. Yes?
You left out laser power beaming and propulsion.
I sure did. Okay. I need to add that in for our, okay, everybody. I left out laser propulsion in the propulsion and transportation. Yes?
It wasn't just laser, it was also microwave. So if you're going to
Okay, photonic.
Power beaming, it should be both laser and microwave.
Or photonic.
That's okay with me.
Okay, good.
But John's preference for laser is not universally shared.
Yes, well,
Almost universal.
okay, so let that be noted, that this will get changed, add photonic propulsion in there.
It's power transfer, it's not only for propulsion.
Okay, power, so
Power beaming
for both power and propulsion. Okay, good, thank you. Okay, the nature of what you heard. Remember, each presenter was here because they wanted to talk. They wanted to say something. They're passionate about his or her presentation. The science needs to be tested. The engineering needs to be tested. The results have to be compared with others for cost, efficiency, synergy, etc. Other technologies are relevant. Remember, I mentioned yesterday that nobody was talking about putting screen doors in submarines or airlocks on spacecraft until today. Somebody mentioned airlocks. Those other technologies are relevant. We just didn't talk about a bunch of them. We did gather the best that we could find. We may have missed some. Some may have been unable to attend. I'm left off pure dumbitude on our part, but because that was mainly John, and so I left it off. We are advocating for broadened technology developments to open the option space and benefit from synergies. And we want to encourage a sense of wonder. This is several years ago, a guy named Shakespeare said, "There are more things in heaven and earth, Horatio, than are dreamt of in your philosophy." We know a lot, but there's more we don't know. Science fiction permits search for novel technologies, examination of ramifications, Gedanken experiments, exploration of concepts, demand for loopholes. Okay, I like this one. You may not be able to read it, so I'll read it. God, why is quantum mechanics so weird? It's Noah's fault. After the flood, I wanted to make a rainbow for him. In order to make a rainbow, you have to break light into wavelengths when it encounters a new medium. Well, it turns out that if you want that, you have to twiddle with a bunch of aspects of the universe, adding weird stuff like photon superposition and probability amplitudes. But every time I fixed one thing, something else seemed to break. So I kept changing things, and the system got more and more hacky as time went on. Finally, it got so fundamentally ugly, I added uncertainty so nobody could look too close. That explains all of physics and what you said to Noah after the flood. Exactly. Never again.
That's great.
Okay. Yeah.
I think y'all did a great job of trying to bridge from the imaginary to the real. And the only way we're going to get to the imaginary future is through reality. And we've made a lot of progress as a civilization since the dawn of spaceflight. I wish we had more leaders like Wernher von Braun to help us today, but there are many leaders, and they're scattered across, including at today's symposium. Thank you very much, John, for organizing this symposium. I'm very pleased to have attended it, and I certainly hope we get the test bed to try as many of these technologies out as we can.